956. Consider the triangles at right. Are the two triangles at right similar, and how do you know? Well, remember, in order to be similar, they need to have two of the same angles. That's what we talked about in an earlier lesson, and it looks like they both have a right angle and a 32-degree angle. So yes, these would be similar triangles. So we can say the triangles are similar. And that would be according to the angle similarity theorem. And really what that means is just saying they both share a 90-degree angle and 32-degree angle. And that just means that by default, that third angle is going to have to be the same in both. So yes, these two triangles are similar according to the angle theorem. All right, let's have a look at B. B says to find the value of x and show your strategy. So for me, I think what I would do to find the value of x, which is right here, is probably set up a proportion. So what I need to do is find my corresponding side with x. So I have x, and x's corresponding side is 15. So we're going to do 15 over x. It's always dilated over original. So we're going to say this is our dilated, this is our original. So 15 over x, and we have to set that equal to another pair of corresponding sides. So I don't know the length of the diagonal or the hypotenuse, but what I do know is this side right here. And if I'm doing dilated over original, it's going to be 24 over 8. So now what I need to do is just cross multiply. So you'll see that I'm cross multiplying x and 24. So 24 times x is going to give me 24x. And then I'm going to set that equal to 15 over 8. I'm sorry, not 15 over 8, 15 times 8. And that's going to give me 120. So now my last step is to get x by itself. So I want to divide by 24. I have to do that on both sides. So I'm left with x equals 120 divided by 24 is going to give me 5. All right, 5 what? 5 feet, 5 inches, 5 millimeters, 5 centimeters. All right, so make sure you label that. X equals 5 centimeters. That's all we have to do for B. So let's have a look at C now. So C says, what is the scale factor? And what they mean is we're going to do big over small. So they're just saying, hey, we're going to do that dilated side, which in this case is the larger one. Not always, but in this case it is, over the small. So we're going to use what sides we do have if we're looking at a set of corresponding sides. So I have these sides are corresponding sides, and the large over the small is 24 over 8. So my scale factor, which can be represented with R, equals 24 over 8. And simplified, that is going to be 3. So our scale factor is 3. Nice and easy. All right, let's go ahead and do part D. Now, D tells us to find the area of each triangle. So in order to do this, you need to know the area formula for a triangle. And for a triangle, that's going to be our area equals 1/2 of the base times the height. So let's go ahead and have a look at that smaller triangle first. So our area is equal to 1/2 of the base. Now my base is 8 and my height is x. Now we determined in part B that x was 5 centimeters, so we're going to plug in 5 for that height. Now my area equals 1/2 times 8 is 4, and bring down my 5. So we're left with 4 times 5, which is 20. All right, don't forget to label this. The labeling is important. So it's 20 centimeters. You need to make sure it's squared as well since we're dealing with area, because area is squarea. So our area of the smaller is 20 centimeters squared. Let's have a look at the larger. So we have our base here. And we know that our area is 1/2 of the base, which is in this case 24, times the height, which in this case is 15. So I have, now what you could do is you could just plug all of this into your calculator. In fact, I would recommend it. You know, if you want to do this in your brain, that's fantastic, but absolutely check it in a calculator to be sure. So 1/2 times 24 is going to give me 12. So I'll bring down my 15. So we're left with an area of 12 times 15, and 12 times 15 should give me 180. So our area for the larger triangle is 180 centimeters. Don't forget that squared. All right, and that's all we've got for 956.